Hello dear student, you are welcome to session 10 of Core Mathematics for SHS. So under this session we'll be looking at simultaneous equations. Alright, so let's quickly look at the session outline. So by the end of this session you should be able to find the solution set of two linear equations in two variables, solve simultaneous equations using the elimination method, and then solve simultaneous equation using the substitution method, as well as solve word problems involving simultaneous linear equations. Okay, so let's set the ball rolling. Okay, so I think we've looked at equations and inequalities, right? So with simultaneous equations, it involves two different linear equations, right? Two different linear equations, and so far the linear equations that we've looked at, they are all linear equations in one variable. That is, you have just one letter within that equation. But with simultaneous equation, each equation contains two different variables, right? So for instance, we have 2x plus y is equal to 4, right? So this one becomes a linear equation in two variables, right? You also have another equation, x minus 3y is equal to 6. Right. So for each of the two equations, you have two different variables. So here the two different variables are x and y. Right. Now the aim of solving simultaneous equation is to find the value of the two unknown variables. Just as with linear equations, the purpose is to find the value of that one unknown variable. Right, so that is basically what we are going to talk about under this session, but then we are going to apply the same principles under linear equations, right? Okay, so let's proceed. Okay, so we have two types of, or two methods of solving simultaneous equation. So the first method is known as the elimination method, right? So let's look at how to solve simultaneous equation using the elimination method, right? So to help us go through the process, we have an example here. So assuming we are asked to solve 3x plus 4y minus 6 is equal to 0 and 2x is equal to 5 minus 3y, how do we go about it? Using the elimination method, right? So the first method, or the first rule, is reorder the two equations in the form ax plus by is equal to c and label them, right? So what this point is saying is that when you are given the two equations, you should not just start with it just as they have been arranged. You have to rearrange them, you have to reorder them in a particular format, right? And the format is ax plus by is equal to c. Now the x and the y are your two unknown variables. They are your two unknown variables, the x and y. The a is simply the coefficient of x, b is simply the coefficient of y. So with this equation like this, 3x plus 4y, so our a will be like our 3, and then our b will be our 4 here. But the x and y, they are the unknown variables, right? So when we are given the two equations, the first thing is you have to group the two variables at one side, and the two variables must be equal to the constant or the number. So here we have 3x plus 4y minus 6 is equal to 0. So you have to group all the numbers at one side of the equation and then group the two variables with their respective coefficient at one side. So in the end, you have to have ax plus by. So here it means that when we rearrange this first equation, we are going to have 3x plus 4y. Now because we don't want this negative 6 to be together with the x and y, we have to export it to the right side, right? So when you do that, because it's negative, when it crosses, it becomes positive. So when we rearrange this first equation, we are going to have 3x plus 4y is equal to positive 6. So like you are seeing, the x and the y are at one side, and then the number 6 is at another side. So the first method is saying that let the two variables with their respective coefficients be at one side of the equation, and let the constant, they still represent an ordinary number, right? So a whole number, and let it be at the other side of the equation. So that is step 1. So with this second equation too, we have 2x equal to 5 minus 3y. So we have to bring this negative 3y and come and join the 2x here. So because it's negative, when it crosses, it becomes plus. So we are going to have 2x plus 3y is equal to 5. Right. So after rearranging the two equations in the appropriate format, you label them, right? So this one becomes our equation 1, and then this second equation becomes our equation 2, so that it would help us in making references, right? So if you want to refer to 3x plus 4y is equal to 6, you are going to say equation 1. If you want to refer to 2x plus 3y is equal to 5, we are going to say equation 2, right? So that is the purpose of labeling the two equations. Okay, let's move on. So the next thing is to multiply both sides of the equation, of each equation, by a number that will make the coefficient of one of the unknown variables the same in both equations. Now what this simply means is, okay, before that you have to decide on which variable you want to eliminate. You see, this method is an elimination method. So our aim is to get rid of one of the variables. So we have to put the variables in such a state that at least one of them can cancel out. Now we have x here, we have x here, we have y here, we have y here, right? So assuming we want to eliminate x, now before you can eliminate this x, then the coefficient of the two x in the two equations must be the same, right? So if I want to eliminate x, right, in the two equations, then I have to multiply the two equations by a number that will make the coefficients the same. So you can use the idea of LCM, right? So I can decide to multiply this 3 here by 2, right? So I can decide to multiply equation 1 by 2, right? So when I multiply equation 1 by 2, in the end I'm going to get my coefficient for the x to be 6, right? So if I want to multiply this equation 1 by 2, it's going to be 2 multiplying everything, right? So the 2 is going to multiply everything. So it's going to be 2 times 3x giving us 6x, plus 2 times 4y giving us 8y, plus 2 times 6 giving us 12, right? So I have made the coefficient of x in equation 1 6. Now I have to also make the coefficient of x in equation 2 6 by multiplying equation 2 by 3, because that is how I can make the coefficient of x in equation 2 also become 6, so that I can easily eliminate x. So we are going to multiply equation 2 by what? By 3. So it means I'm going to multiply each term by 3. It's going to affect each and every single term. It is not only the x aspect. It's going to affect each and every single term, right? So it's going to be 3 times 2x giving us this 6x, 3 times 3y giving us 9y, and then 3 times 5 giving us 15, right? So you have to decide which variable you want to eliminate first. Right, so that you multiply the two equations by a number that will make sure that the coefficient of the variable you want to eliminate are the same for the two equations. So here, because I wanted to eliminate x, I multiplied equation 1 by 2 so that the coefficient becomes 6x. So it becomes 6. Now how do I make the coefficient of the x in equation 2 to also become 6? By multiplying it by 3. So I'll multiply equation 2 by what? By 3. So let's now label equation 1 being multiplied by 2 as equation 3. So we have 6x plus 8y is equal to 12. So this is a result of multiplying equation 1 by 2. And that, let's label it equation 3. And let's label equation 2 multiplied by 3 equation 4. So this is the result of multiplying equation 2 by what? By 3. So we had 6x plus 9y is equal to 15. So that gives us equation 4. So the next thing is to eliminate the supposed or the selected variable. So in eliminating, you have to take note of this. If the equal coefficients have the same sign, then you have to subtract the two equations. If they have opposite signs, you have to add the two equations. So here you can see that the coefficient of x in equation 3 is 6. The coefficient of x in equation 4 is also 6. Now they are all positive 6. So when the two coefficients are of the same sign, now in order to eliminate that that variable together with the coefficient, you just subtract it. Because if I have 6, right, and I have another 6, now if I want to eliminate the two 6, what do? I just subtract. So 6 minus 6, right? But then if one is positive and one is negative, I'll add, so that in the end, assuming here was negative 6, it's going to be negative 6 plus 6, and that will still be, that will be 0. Right, so if the coefficients are of the same sign, that is, if they are all positive, you just subtract. Right, if one is negative and one is positive, you just add. Right, so take note of that. So we are subtracting equation 3 from equation 4. So equation 4 minus equation 3. So we had 6x plus 9y is equal to 15 minus 6x plus 8y is equal to 12. Then we are going to subtract each term. We're going to subtract each term. So what is 6x minus 6x? Is 0. So it means that we have eliminated the x completely. So we are left with the 9 aspect and then the whole number aspect. So what is 9y minus 8y? It gives us only y. What is 15 minus 12? It gives us only 3. So it means that our y is equal to positive 3. Right. So since we found y, then it means that we can substitute this value into any of the equations to find the value of x. So let's continue with the steps. So after finding the value of one of the variable, you substitute it in any of the other equations to find the other unknown variable. So here we know that our y is equal to 3. So let's put y is equal to 3 into equation 1. So our equation 1 was 3x plus 4y is equal to 6. So it means that wherever we see y, we are going to replace it with the number 3. So you're going to have 3x plus 4 times 3 is equal to 6. So you're going to have 3x, 4 3 is 12, so 3x plus 12 is equal to 6. And then we find the value of x, so we are going to move this 12 to the right side. So you're going to have 3x equal to 6 minus 12. Right, so 3x is equal to negative 6. And to find x, we divide both sides by positive 3. So that gives us our x to be equal to negative 2. Right, therefore x is equal to negative 2 and y is equal to 3. So that is how to solve simultaneous equation using the elimination method. I believe it's well understood. Okay, let's move on. So the second method of solving simultaneous equation is what we call the substitution method, right? So let's take this example and let's see how to solve simultaneous equation using the substitution method. So we have to solve 2s plus 3t is equal to 16 and 3s minus t is equal to 2. So we are going to repeat the same step as we saw under the elimination method. That's the first step. That's reorder the two equations in the form ax plus by is equal to c and label them, right? So okay, in fact for this one it has been well arranged for us, so there's no need for us to rearrange them. So we just go straight forward and label them, right? So 2s plus 3t is equal to 16, that gives us equation 1. 3s minus t is equal to 2, that gives us equation 2. The next step is to make one of the variables in one equation the subject. So under the substitution, after labeling the two equations, we are going to make one variable the subject in one of the equations. So let's decide to make s the subject in equation 1. So this is our equation 1. So we are making s the subject here, right? So we have 2s is equal to 16 minus 3t, right? So here, because it was 2s plus 3t, we want to make s stand alone. So we just move the 3t to the right side. That's why it became 16 minus 3t. So we divide both sides by 2. So we had 2s over 2 is equal to 16 minus 3t all over 2. So our s is equal to 16 minus 3t all over 2. So this becomes equation 3. Right. So after making one of the variables as subject in one of the equation, we are going to label it as equation 3. Right. Okay, let's move on to the next step. So afterwards, we are going to substitute the third equation obtained into the other equation and solve for the other unknown variable, or solve for one unknown variable. So we are substituting equation 3 into equation 2, right? So this is our equation 2, 3s minus t is equal to 2. And our s was what? Let's look at our s. Our s gave us 16 minus 3t all over 2. Meaning that wherever we see s in equation 2, we are supposed to replace it with 16 minus 3t all over 2. So our equation 2 is 3s minus t is equal to 2. So 3s means 3 times s, and our s is 16 minus 3t all over 2. So we're going to have 3 into bracket 16 minus 3t all over 2 minus t is equal to 2. Because we want to get rid of this denominator 2, you multiply it through by what? By the 2. So we're going to have 2 multiplying the first expression here. Of course, it will cancel out, so leaving us with 3 into bracket 16 minus 3t minus 2 multiplying t, so 2t is equal to 2 multiplying these 2, giving us 4. Alright, so the next thing is to expand this bracket. So 3 times 16 gives us 48. 3 times 3 gives us 3 times negative 3 gives us negative 9. Right, so we're going to have 48 minus 9t, and then you add the minus 2t, everything is equal to 4. The next thing is to group like terms, right? So we have 48 minus 4, so we bring this 4 here, it becomes negative. 48 minus 4 is equal to, now we send this negative 9t to the right side, so it becomes positive 9t, as well as this negative 2t, so it also becomes positive 2t. So we're going to have 44 is equal to 11t. We divide both sides by 11, and our t is equal to 4. Right, so after getting the value of one of the variables, we just substitute it into any of the equations to find the value of the other unknown variable. So it means that wherever we see t, so we can pick any of the equations. So let's pick equation 3. So we are going to substitute t is equal to 4 into equation 3, right, so that we can find the value of s. So we have established that our t is equal to 4. what of our s? So our s is equal to, according to equation 3, our s is equal to 16 minus 3t, right? As you can see here, 16 minus 3t all over 2. So wherever we see t, we replace it with 4. So 16 minus 3 times 4 all over 2. You're going to have 16 minus 3, 4 is 12 all over 2. So 16 minus 12 gives us 4, and 4 divided by 2 gives us 2, right? So our s is equal to 2 and our t is equal to 4. As simple as ABC, right? So that is how to solve simultaneous equation using the substitution method. So you make one variable the subject. So here we made s the subject. Afterwards, we are going to substitute the third equation into the second equation, and then you find the value of one of the variables. Afterwards, you are going to substitute it into any of the other equations to find the value of the other unknown variable. So that is as simple as that for the substitution method. I believe it's well understood. Okay, let's proceed. Alright, let's look at word problems. So there are times that you'll be given a statement, right? A statement. You wouldn't see, or you wouldn't be given two equations, as in terms of mathematics. You'll be given a statement, right? But then you can deduce, or you can form two different equations out of that particular statement, and that will result in a simultaneous equation, right? So let's look at the typical example here. So the sum of two positive numbers is 29 and their difference is 17. Find the two numbers, right? So you see here it speaks of two numbers, two things, two different things. So we don't know those two different numbers, so why not represent them by variables? In maths, we always use variables or letters to represent unknown numbers, right? So since we don't know those two unknown numbers, then let x and y represent the two numbers that we don't know, right? And then let's study the statement very well. It says the sum of two positive numbers is 29. Now, how do you represent, or how do you interpret sum mathematically? When I say the sum of 2 and 3, how do you write it mathematically? It's simply 2 plus 3, right? So here we know that our two numbers is x and y. So if I say the sum of two positive numbers is 29, what this simply means is x plus y is equal to 29. So that gives us our equation 1 straight away, right? And then it says and their difference is 17. Now difference in mathematics means subtraction. So if I say the difference between 9 and 3 is 6, right? So it means 9 minus 3 is equal to 6. So if it says and their difference is 17, it means that the difference between the two numbers gives us 17. So the two numbers here are x and y. So it means x minus y is equal to 17, and that gives us equation 2. Sorry for this mistake. Let me correct it. Okay, let me correct it. It's supposed to be 2, right? Yeah. So x plus y is equal to 29. That's equation 1. X minus y is equal to 17. That gives us equation 2. Right. So though the question didn't explicitly give you these two equations, based on what you were told, you've been able to deduce the two equations, hence simultaneous equation, right? So you can use any of the methods to solve it. You can decide to use the elimination method or the substitution method, but here I use the substitution method, okay? But then of course you can apply, or you can make use of the elimination method, and you would still arrive at the same answer, right? Okay, so let's make x the subject in equation 1. So we have x plus y is equal to 29. So we are going to move this y to the right side so that it becomes negative. So it becomes x is equal to 29 minus y. That gives us, or that becomes our equation 3. Then we'll substitute equation 3 into equation 2. So x minus y is equal to 17. That is equation 2. So it means that wherever we see x, we are going to replace it with 29 minus y. So here we have 29 minus y is equal to 17. So we want to make, okay, so minus y gives us minus 2y. So we have 29 minus 2y is equal to 17. Now I want to make y the subject. Okay, so what I did was I moved the negative 2y to the right side, right? And I brought the 17 to the left side. So it becomes 29 minus 17. Here was plus, so it becomes minus. And then the negative 2y becomes positive 2y at the other side. So 29 minus 17 gives us 12. So we are going to have 12 is equal to 2y. When you divide both sides by 2, you are going to have your y to be equal to 6. So you simply substitute y is equal to 6 into equation 3 or into any of the other equations, right? So x is equal to 29 minus y. That is our equation 3. So wherever we see y, we are going to fix 6 in place of y. So it means x is equal to 29 minus 6. And 29 minus 6 gives us 23. Therefore, x is what? 23. So our two numbers here are 6 and 23. Now let's see whether we are right or wrong. Okay, in maths you can always prove your answer. In most cases you can prove or you can test whether your answer is correct or wrong. So it says the sum of two positive numbers is 29. So is it true that when I add 6 to 23 I'm going to get 29? Yes, of course, right? And their difference is 17. So is it true that when I subtract 6 from 23, I'm going to get 17? Yes, the answer is yes. So it means that we are right. Okay, so let's look at another question here. Okay, so it says Prince was twice. Sorry, I skipped the second one. So let's look at this, the second word problem. One notebook and 2 pens cost $14. Two notebooks and 3 pens cost $24. How much does each notebook and each pen cost? Right? So since we don't know the price of each pen and the price of each notebook, let's represent them by variables, right? So let P be equal to the cost of one pen and N be equal to the cost of one notebook, right? And then let's interpret the statement here mathematically. So it says one notebook and 2 pens cost 14 cedis, meaning that the sum or the addition of the cost of one notebook and the cost of 2 pens will give us a total of 14. So how do you represent it as an equation? Well, we said that N represents the cost of one notebook. So as the statement goes, one notebook, so 1N, that is the same as N, plus, whenever you say N in mathematical sense means addition or plus, and 2 pens, so plus 2p is equal to 14. So that gives us our equation 1. Now the second sentence says that 2 notebooks and 3 pens cost 24 cedis. So 2n, right, and plus 3p gives us, so it's equal to 24. So that gives us, or that becomes our equation 2, right? So the next thing is to, so here I also use the substitution method, right? It is the easiest, or let me say it is the most common method to use, right, as far as simultaneous equation is concerned. So in making n the subject in equation 1, you're going to have n is equal to 14 minus 2p, right? So we label this one as equation 3, and then we substitute equation 3 into equation 2. So it means wherever we see and we are going to replace it with 14 minus 2p. So our equation 2 is 2n plus 3p is equal to 24. So we are going to replace this n by 14 minus 2p. So we're going to have 2 into brackets 14 minus 2p plus 3p is equal to 24. So 2 times 14 gives us 28. 2 times negative 2p gives us negative 4p. Then plus 3p is equal to 24. So I decided to take the 4p and the 3p to the right side, and then I brought the 24 to the left side. So in the end you have 28 minus 24 is equal to 4p minus 3p. So 28 minus 24 gives us 4. 4p minus 3p gives us p. So p is equal to 4. So we can substitute p is equal to 4 into any of the equations. So let's substitute it into equation 3. So our equation 3 was n is equal to 14 minus 2p. So wherever we see p, we are going to put 4 there. So we are going to have n is equal to 14 minus 2 times 4, giving us 14 minus 8. And 14 minus 8 is 6. So our n is 6. Therefore, one notebook cost $6 and one pen cost $4. Right? As simple as that. Right? So you just have to read the statement and then analyze it and then interpret them mathematically. Right? It is very simple. It is very simple and straightforward. Let's look at our final word problem. So Prince was twice as old as his younger brother 6 years ago. If the sum of the present ages of Prince and his younger brother is 30, find their present ages. Alright. So here too, we don't know their ages, right? So let x represent the present age of Prince, and let y represent the present age of his younger brother. Right? And then let's come back to the question and interpret it mathematically. So Prince was twice as old as his younger brother 6 years ago. Alright, so how do you represent it mathematically? So x is the age of Prince. In fact, x is the present age of Prince. So how do you find the age of Prince 6 years ago? Assuming you are currently 17 years old. How would you find your age 6 years ago? It will simply be your present age minus 6, right? So x is the present age of Prince. So Prince's age 6 years ago is simply going to be x minus 6. Right? So it says Prince was twice as old as his brother 6 years ago. So it means that when you compare Prince's age 6 years ago to his younger brother, to his younger brother's age 6 years ago, Prince's age will be twice his younger brother's age 6 years ago. So this is simple. This is Prince's age 6 years ago, x minus 6. So it means that his age is equal to twice his younger brother's age, as the sentence clearly states here. So Prince's age is twice, 2 times. So what is his younger brother's age 6 years ago? It is also going to be y minus 6, because y is the present age of his younger brother. So if you want to find his age 6 years ago, it's going to be y minus 6. So x minus 6 is Prince's age 6 years ago. Y minus 6 is Prince's younger brother's age 6 years ago. But then the relationship is such that Prince's age 6 years ago is 2 times. So x minus 6 is 2 times y minus 6. Y minus 6 is the age of his younger brother 6 years ago. And that is what is illustrated by this sentence over here. That his age 6 years ago, which is x minus 6, is equal to twice his younger brother's age 6 years ago, which is y minus 6. So that gives us equation 1. I believe you get it. Okay, let's move on. If the sum of the present ages of Prince and his younger brother is 30, find their present ages. So this is simple. So x plus y is equal to 30. The sum means addition of the present ages of Prince and his younger brother. So the present age of Prince is X, so X plus the present age of his younger brother Y, right, gives us a total of 30. So X plus Y is equal to 30, and that gives us equation 2. So we want to make X the subject in equation 1. So you're going to have X minus 6 equal to 2 into bracket Y minus 6. So you're going to expand this bracket, and you're going to have X equal to 2Y minus 12 plus 6. Actually, I brought the minus 6 here straight away, right? So the bracket will give us 2Y minus 12, and then I brought a negative 6 here, so it became plus 6. So you're going to have X is equal to 2Y minus 6. So negative 12 plus 6 will give you negative 6. So this becomes sort of our equation 3. So you're going to replace or substitute equation 3 into equation 2. So our equation 2 is X plus Y is equal to 30. So wherever I see X, I'm going to replace it with 2Y minus 6. So X plus Y is equal to 30. So that gives me 2Y minus 6 plus Y is equal to 30. So 2Y plus Y, right, is equal to 30 plus 6. So I brought a negative 6 to the right side. It became plus 6. So 2Y plus Y gives me 3Y. So you're going to have 3Y is equal to 36. You divide both sides by the 3. You're going to have Y is equal to 36 over 3 give you 12. So Y is equal to 12. Right, so that is the value of Y. Now you want to find the value of X now. So we substitute Y is equal to 12 into equation 3. Sorry, I have to change this one to 12. Sorry. Yeah, so we have Y is equal to 12. So you're going to place 12 at wherever we see Y, right? So our equation 3 was 2Y minus 6, right? X equal to 2Y minus 6. So our X equal to 2 times 12 minus 6. So X equal to 24 minus 6, and that gives us 18, right? So it means that the value of X is 18 and the value of Y is 12. But with word problems, you don't end at just finding the value of the two unknown variables. Afterwards, you are going to explain, or you are going to state that the age of Prince is 18 and the age of his younger brother is 12, because the question didn't ask you to find the value of X and Y. In fact, the X and Y came from you, right? The question asked you to find the present ages of Prince and his younger brother. So after solving everything, you come and conclude that therefore Prince is 18 years while his younger brother is 12 years. So the present age of Prince is 18 years and the present age of his younger brother is 12 years. Right, so that is how to solve word problems under simultaneous equations. Right. So this is where we bring the lesson to an end.